Welcome to the Real Python Podcast. This is episode 154. Are you familiar with the different versions of WebAssembly? Could WASM be the write once, run everywhere solution developers have searched for? Where does distributing Python applications fit in the narrative? This week on the show, we have CPython core developer Brett Cannon to discuss his recent articles about WebAssembly and MVPy. Brett has completed his Syntactic Sugar series, which we discussed in a previous episode. He details the origin of the series and his process of unearthing a minimum viable version of Python. Brett shares how he updated his PyCon US talk on the subject after feedback from presenting it at PyCascades. We also dig deep into WebAssembly, specifically WebAssembly System Interface, or WASI. Brett explains the concept of a platform target triple and the importance of defining what system CPython is compiled for. We also discuss WebAssembly becoming a ubiquitous distribution system. This episode is brought to you by Courier. Courier is a developer platform for notifications, providing powerful API primitives for building notifications that perfectly fit your app UX. Get started for free at courier.com. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Brett, welcome back to the show.
Thanks for having me back.
It was so cool to meet you in person up there in Vancouver a couple weeks ago.
Yeah, it was a lot of fun. It was actually this for PyCascades 2023 in Vancouver, and it's actually the first conference since I think actually PyCon US 2019 for me.
Yeah,
if you don't count the Python core dev sprints. So it was exhausting, but great.
Yeah,
not used to being around that many number of people and talking that long and standing on my feet that long. So
yeah, is that the first sort of presentation, or have you done any virtual ones?
Good question. I honestly don't remember.
Okay.
Yeah, I don't know.
Because you gave a talk that we'll discuss a little bit here in a minute.
Yes.
Yeah. And I want to thank you for the thorough tutorial on Marvel Snap. That was really nice. Thanks.
You're quite welcome.
One thing we talked about, I guess it was just over a year ago, we were talking about how you would use the internet to sort of survey ideas and things that you wanted to propose to the community and ask questions. And you used to use a former social media site. You've sort of transitioned to Mastodon, I think, completely. I'm wondering how that's going, I guess, first.
Yeah, so I actually tried a couple times to see if I could get the Python community off of Twitter and failed. And then certain decisions and actions, the late 2022 made that decision for the community on my behalf. So that worked out.
Yeah.
But yeah, I completely jumped ship over to Mastodon. And I think I completed the transition at the end of November. It honestly has gone well for me. Follower counts dropped significantly, but I honestly was never on Twitter for follower count. I was there really just to engage with the community and just to talk with people. And enough of the wonderful, nice people in the community moved over to Mastodon that it's worked out great. I still run polls on occasion to try to get feedback from the community.
Yeah, that's what I was going to wonder, is if you got enough input or information from your polls with, say, a smaller follower count. Is it still working good?
Yeah, I mean, I never expect the polls to be definitive, right? There's selection bias, obviously, with who chooses to follow me and thus respond to the polls. The numbers is never large enough to match the, let's be honest, probably tens of millions of Python users are out there at this point.
Yeah.
So I never view them in any way in terms of anything other than to see if I happen to think I have a blind spot or a bias that at least some people might not hold, or to honestly see what the responses are and to see if there's something I hadn't thought of. But it's mainly just to see, like, I might think something is not that popular does that hold true? Or is the community going to shock me and go like, oh yeah, actually out of 100 people, half of them actually do use this thing or technique or approach or whatever that I actually thought hardly anyone did. So it's more just trying to verify that I don't have a blind spot. And yeah, it continues to work even over on Mastodon.
Cool. Yeah. It seems like that process is still something you're engaging in and back and forth between, like, should this be potentially proposed as a PEP? And that feedback loop seems to still be working pretty well for you.
Yeah, I mean, admittedly, I do have a lot of random ideas, and a lot of the questions I ask are like for projects that literally might not take on and come to fruition for years, but there are reasons I'm asking them. They're never completely superfluous. And if they are, I try to be honest. Like, I'm just curious.
Yeah.
And it's just ask, just to see what the conversation goes, see if it sparks interest for anyone. But sometimes, honestly, most of the time, there's a kernel of a purpose. It just might not be obvious for quite some time until people realize why I asked. So,
yeah. And then it shows up on your blog.
Yeah.
Or somewhere else. Yeah. Congratulations on completing the Syntactic Sugar / Unraveling series on your blog.
Thank you. Yeah, that started back in, what was that, June of 2020? Yeah, I think it was 2020. To be honest, I just edited one of the posts yesterday. So
yeah.
Well over 2.5 years.
You did a presentation at PyCascades, and it looks like you're going to do it kind of maybe a slightly modified one based on our earlier conversation one coming here at PyCon US.
Yeah, exactly. I actually gave that talk, and then afterwards I had multiple people come up to me. Because in the talk, so for the blog post series, for those of you who aren't familiar with it, I basically just looked at all of Python's syntax in Python 3.8, because back in 2020, that was the latest release.
Right.
And just kind of looked at like what really has to be there and what could you actually re-implement yourself by hand in Python code, and with other rules and stuff we can talk about if you want.
Yeah.
But as part of the final post, I listed the things I couldn't figure out a way to get rid of based on the restrictions I placed on myself. And when I presented that list of 11 things at PyCascades, I had people come up to me and say, on 2 or 3 of them, it's like, I actually don't know if you really need to keep that on that list. I think you can get rid of it.
Okay.
And lo and behold, on 2 of them, I got rid of them. And the third one, I'd have to change some things, or actually I took away one of my rules that I bent for myself and put something back on that I had taken off. So honestly, I didn't have to unravel one of the things. So it's back to 10, but it's still changed. So if you're coming to PyCon and you saw my PyCascades talk, it will at least be tweaked in case you come here at a second time.
It'll be fresh.
Yeah.
That's nice. Yeah, I think we talked about it in an earlier episode. I'll have to look at the number here and add it in. But one of the things I asked you back then was this concept of like, okay, well, as a beginner or intermediate person, you hear this term syntactic sugar and you're like, wow, that sounds very fancy. What is it? And I'm trying to remember your explanation.
I can't remember, honestly, back then either. It changes constantly. But I think saying fancy is kind of a good point, right? Syntactic sugar is just kind of, it's a bit of fancy in your code to make your life easier. It's syntax that's actually technically not necessary to end up at the exact same semantic result, which is a very fancy way of just saying, if you didn't have this syntax, you could still get your job done and still end up at the same endpoint.
Right.
It just might, and hopefully does, make your life way easier and better, right? Like the canonical example I use is plus. Turns out you actually don't need plus in Python. You can totally make it work without it. It just is a lot of lines of code to make it work appropriately in the same way. Or you can just literally write one little ASCII character that looks like a plus and have it do the same thing for you. That's syntactic sugar.
Okay. So generally, all the different operators, or most of them, would be considered potentially syntactic sugar then.
If I'm not wrong, all but 10.
Okay. All the different items. So then you talk about rewriting them. And I kind of think there's some interesting maybe rules there that I'm wondering, okay, so if you have these 10 items, you can use those 10 items in the rewriting then of these other pieces of syntax.
Yeah, I mean, basically the rules I set out for myself in the blog series was the restrictions in terms of could I unravel something from Syntactic Sugar down to its like base components was that it had to be in 3.8. It was okay to make things look a little wonky if you called globals or locals, those built-in functions, right? Because you're kind of peeking under the hood in terms of how things execute. And you might be surprised if you ever call the locals function inside the list comprehension, you're going to notice there's actually a magical little thing you didn't know about, slight Easter egg for CPython users. And so I figured if we're already doing that in some places, I could cheat that way too. And then I didn't care about performance, right? This is not meant to be faster or comparative because that's just not possible, right? I'm taking a bunch of stuff that's done in C code, at least in CPython, or stuff that PyPy gets to jit away at lower levels and certain things, and I'm unraveling it all. So it's just not quite equivalent. But then the last one is I said the translation from the syntactic sugar down to its base components had to be within a single file.
Okay.
And the reason I did that is I wanted to be able to conceptually have a tool that I could pass a file to, or pass a file to the tool, and have it spit out a copy of that file with all of the syntactic sugar unraveled.
Okay.
But have it still work the same as if you didn't know that happened, right? So you could still import that code and have it still lead to the same result. And that tweaks some things because it means, for instance, I can't change how function calls work, right? Because if I could look at your entire code base and change your whole code base as one big unit, I could go like, oh, well, I don't need exceptions anymore because I can just make everything return either, and this is how Rust actually does it, I can make everything either return okay with the result or error with the exception that's being raised.
Okay.
Right? And so I can do everything with returns. I don't even have to have try except blocks or any of this other stuff. But because I gave that restriction that I wanted to be able to take a file on its own, translate it, and have any other code that used it not be able to tell that it was unraveled, that prevented that. So I had to make sure anything I kept would allow me to keep the API around, right? So I had to make sure any functions that existed or any methods or classes still work as normal. So that was an interesting little restriction in terms of what I could get rid of. Because if I could do the whole code base, I could actually get that list of 10 down even lower. But I decided not to go that route because honestly, I only have so much time and I had to finish the blog post at some point.
Yeah. And along the way, you're doing a lot of, disassembling the dis function to kind of look at the C code underneath it and using that in some of the definitely a lot of the earlier blogs would get somebody sort of on board with the methodology because they became shorter as you kind of went, depending on what you were unraveling.
Yeah.
And you don't want to repeat yourself, I'm sure. But I think if somebody really wanted to dig into the complexity of it, you have a GitHub, right, that has all of it. Like people can kind of check out how it all looks unraveled, right?
Yeah, so there were a couple layers to it. So in the earlier posts, I actually ran the dist module, as you said, and looked at the actual underlying bytecode. And then I would map the bytecode actually to the C code and point out to people what was actually happening underneath the hood.
Okay.
And then from that point, I was able to then hopefully explain to readers that, okay, so because this piece of syntax unravels to this bytecode and that bytecode goes down to the C code, you can understand semantically what's going on. So from that perspective, you can just kind of map that back to actual straight Python code and have it worked out. And early on, for anything where I re-implemented stuff like that to basic Python semantics that were very clear, especially when it mapped back to like built-in functions, right? So I think if you look at like the unraveling of the for loop, like I unravel how the iter built-in function works to kind of explain how the semantics and all that function. And I do have a repository on github.com/brettcannon/dsugar, DESUGAR, and put all that code up there initially. I honestly stopped doing it because I stopped unraveling things that I could kind of map back down to built-in functions that would then unravel.
Yeah, okay.
And honestly, I had to get the blog post series done. As I said, it took over 2.5 years. And at some point I had to go like, okay, I've given everyone who's interested the tools that hopefully they need if they were interested in figuring out all the lower level details like that.
Okay.
But I just had to get the thing done. Like, it's like, I knew this was probably going to be the next talk I gave at some conference. I was hoping the pandemic was going to end someday. So it was just like, okay, I can keep doing all this unraveling, but it's a lot of work to do all that extra mapping when I already know the semantics pretty well, or I can go read the language spec and get the semantics. So I honestly just kind of tapered those off because I had to get it done. And honestly, my wife, Andrea, was getting driven nuts having to proofread all those posts. And she was wanting to proofread less and less. So to make my own proofreading easier, I just wrote less and less.
Yeah, that makes it easier.
They all still cover it. But yeah, you're right. The detail did kind of taper off towards the end, I will fully admit.
No, it makes sense too. I mean, you kind of learn the methodology as you go through it. There's 32 posts, so I feel like you can start to summarize yourself slightly in the steps and say, okay, this thing.
Exactly.
So you called it MVPy, the minimum viable Python, and I think it goes back to when I had read your initial blog post and I got very interested in this a year and a half ago. I was like, oh, this looks like you have a goal in mind, which was to get things down to its core elements, like what is Python, and that had to do a little bit with this idea of maybe moving toward WebAssembly. And wow, a lot's happened in the last 2 years with all of that, and you're involved in a lot of it. And so I don't know if you want to talk about that, the beginnings of it also, and why you kind of embarked on it.
Yeah, I mean, you're totally right. Basically, when my wife Andrea sent me down this journey on WebAssembly, and that's no joke, my wife was doing a data science course at UBC, University of British Columbia, here in Vancouver, which she completed.
Yay.
And while she was doing it, like first week, she was doing an assignment, I think, and is all done in Jupyter Notebooks. And she stepped away for like an hour or something, I think, to have dinner or something, and went back, and she was disconnected. And she was like, why isn't this working? And it's like, oh, well, they're using a technology called Jupyter Hub, right? Where they've got some servers over at UBC that are running and hosting your Jupyter Notebook. And when you hit the run button, it's running on those servers and sending the result back to your browser. So you just got disconnected from the servers. I said, well, I thought this was running in the browser. And it's like, no. Python doesn't run in the browser. There's this thing called WebAssembly that I've been thinking about, and it's probably could work, but no one's done it yet. I'm thinking about it a little bit, and I'll never forget this. I was in the car. If you're a local, you know where I'm talking about. We were on Hastings, right next to the P&E, going east towards Burnaby. And she literally just, while I was driving, I explained this all to her. She just said, you should fix that. I was like, okay, I don't think you realize what you're asking here. Like, this is a multi-year project to get Python in the browser, et cetera, et cetera. And literally split second after I said all that, she just thought for a second and went, no, you should fix that. So
wow. Yeah.
That led to this blog post series, because the first thing I thought about was like, okay, how do I get Python in the browser? And part of that was, all right, do I have to re-implement Python, like CPython in WebAssembly? Like, do I have to go all the way down to, could I compile Python straight to WebAssembly? Could I even do that? Like, what would that entail? And so my brain went like, well, what do I have to do? What really is Python? Right? Like, this is when I did some, back when I was on Twitter, I had some tweets where I said, like, you know what? The REPL really isn't part of Python, right? So, because if I compile Python, I won't really have a REPL, because the WebAssembly security model, you can't dynamically create and run WebAssembly code. It has to be all kind of known up front, because it scans it and makes sure it's valid. So it's like, I guess I really don't need the REPL. It's not technically part of Python. It's just a tool that's extremely useful, don't get me wrong, that ships typically with it. But honestly, do you have to have a REPL to call yourself Python? And so when I just went down that road, I inevitably just kept thinking about, like, really, what is that minimum viable version of Python that if I had that, everything else could be built from it?
Yeah.
And because that would be what I would have to re-implement if I was going to compile Python down to WebAssembly. And that's what led to this blog post. It was just like, how small could I potentially make an interpreter or compiler for Python and somehow get semantically back up to what Python 3.8 is? And that's the blog post series.
Well, congratulations.
Yeah. I don't know if I could actually make a compiler work exactly the way people might expect Python to function, just because there's enough dynamicism to it that it might not, but it was still at least an interesting exercise regardless.
Yeah. And what's interesting is I feel like I'm sure there's a lot of cross-pollination that was happening right at that moment between multiple people and kind of the, I don't know, zeitgeist or whatever, this idea of like, hey, we want to do this too. Were you communicating with other teams about the idea of Python in the browser in those early days of thinking about this and looking at their work and sharing notes, or was this done kind of mostly on your own initially?
The blog post series was mostly on my own. I was not hiding the fact that I was thinking about WebAssembly, but I wasn't seeking anyone out because I was still trying to figure out how this whole approach would work. Like, what would be required? Like, what could I do short term? What could I do medium term? What could I do long term? Right? Because
Yeah.
when I think of Python projects that I take on, there's the little thing like 100-line projects like MicroPython that I can write in 100 lines and do roughly in a day. And then there's projects I have that are going to take literally years because they require come up with the idea, reach a consensus with people, writing the PEPs, getting them out, and then getting everyone to support what the PEP proposed. So I want to kind of like, what could I do in less than a year? What could I do like in less than 5 years? And what would take like 10 years? And like compiler would be like 10 years, if at all.
Yeah.
Right. And so I was always just kind of talking about like, what would it take to kind of like compile Python itself and all that. So I was talking about it out loud. And then that subsequently led to Python core dev sprints in 2021, and then that's when Christian Himes got involved, and then Christian helped with all that up until roughly the core dev sprints in this past year in 2022, and then other people have obviously come along and gotten involved in various levels, and now we're kind of at this current situation where we're at.
For web and mobile apps, delivering the right message in the right channel and at the right time to end users can be a massive challenge. Courier abstracts the complexity behind delivering a modern notification experience. With elegant API primitives for developers, UI components that follow the example of world-class apps, and beautifully designed no-code tools for product owners, notifications can now be a natural extension to the tech stack. Get started easily with their Python SDK and start sending notifications for free at courier.com. One of the things that has been around a little while now with WebAssembly, this sort of WASM, in the big release last year at PyCon was sort of PyScript on top of that, and some interesting tooling, probably the one that most people are maybe have seen out in the world if they haven't talked about it much. Behind the scene, it has been using a tool of mscriptum. Is Christian involved in that one, or who's the team that does the mscriptum?
No, well, so it depends on how you define it. So actually, Christian's taking a break from open source right now.
Okay.
So in terms of that stuff, that's mostly, they'd be the people from Pyodide.
Okay, Pyodide.
So people,
I'm sorry, I'm getting the name wrong.
Yeah, no, it's fine. Well, so PyScript runs on top of Pyodide, and then Pyodide uses mscripton to make Python work. So the way this whole stack works, right, is there's CPython at the base layer, right? The implementation that everyone ends up using. There's a tool called mscripton, emscript-en, and what it does is it basically compiles C code to WebAssembly, but it does it specifically for the browser, right? So it totally leans in on browser APIs to provide things like file access and that kind of thing. And then what Pyodide does is they take and use mscripton to compile CPython and add some extra niceties to make it run in the browser well. And then PyScript basically built on top of that to provide what it adds in terms of specifying packages to install and its GUI stuff and all that. And actually, since all that's happened, Nicholas Tollervey, who works at Anaconda, who drive all the PyScript work, he actually got MicroPython working on top of PyScript. So they've actually taken PyScript and made it kind of Python runtime agnostic, effectively.
Okay.
So you could plug in MicroPython, you can plug in Pyodide, and what have you. Now, so obviously MicroPython is a complete separate thing, implemented from scratch. It's not even a fork of CPython. For Pyodide, a lot of the work that Christian did for them was he took a lot of their patches and put them into mainstream. So he worked them upstream into CPython itself. So you can currently take CPython itself with mscripton and compile it and spit out the HTML and JavaScript and have it just basically have the WASM file you can just load. It's very rough. It's not what you're going to want to use. You're going to want to grab PyODI because they add a lot of extra niceties that make it work better. But at least they don't have to maintain patches against the CPython code base to make it just compile. So that's kind of the whole hierarchy of stack from the browser side of things.
Do you feel with these set of tools that what your wife was looking for is solved in some ways? Are there still some things missing that it needs to be that replacement for, say, a Jupyter or what have you?
Well, so it kind of depends on your view, right? So there's Jupyter Lite, which runs in the browser and is actually Jupyter fully self-contained running in the browser, right? So that's actually there.
Yeah.
The real trick is going to be the packaging story, right? Which is almost always the story for most languages these days.
Yeah, it seems to be.
So I think that is a problem that's still being worked on. On the browser side of things, the QuantStack folk are trying to create something called Inscription Forge, where they take Conda Forge and use Conda Build to try to build all the Conda packages for Inscription, which would mean it could work with PyODI and anything else built on top of that. I don't know the status of that project. They announced that in a blog post last year in 2022, I think mid 2022 maybe. But I don't know the status of that. But that's, I think, the key status point for the browser stuff is probably still trying to figure out the packaging story. They can install stuff from PyPI that's pure Python. It doesn't use anything that's not supported by Inscription.
Okay.
So it's definitely not zero. It's just, can you get an extension module compiled for it? Yes or no? That's always the question.
Okay. So there's a subset of things that you're going to have to just sort of look at and make sure it's approved list of stuff. Yeah.
Yeah. Just because it works on CPython on your desktop does not mean it's going to naturally work in the browser.
Yeah. So you've had a couple blog posts recently that kind of are in this realm too. And the one you did in December was WebAssembly and its platform targets. And this is something that I've been wondering a lot about, where you talk about kind of the differences between WASM and WASI. WASM is WebAssembly, basically kind of a weird mashup of those letters.
Yep.
And then WASI is WebAssembly System Interface. I'm not sure if I've got that right.
No, you got it right.
Okay, good. Okay. And so what I feel like is partly the idea of like, okay, we want to put in packages and we want to have things be able to talk, but a browser is a sandbox. There's things that are kind of walls that are around it, whereas potentially the idea with WASI is to make an application that goes maybe a little bit further and has more, I don't know, almost permissions to kind of break outside the sandbox. You can correct me if I'm wrong, but I'm still kind of trying to figure out like, okay, well, I see a lot of people talking about it and I can kind of understand it. You mentioned like access to files, and I know that WASM already has some problems with that, like just like, what will your browser allow and so forth, and getting like a permission dialogue. I guess if the resources you need are out on the web, that's easier, like grabbing data or other things like that. But potentially I'm wondering if that is part of what we're looking at, and then maybe going further and talking about integrating with other system things like serial connections or other stuff like that, if that's part of what WASI is trying to do.
So I think the best way to explain this is that there's another hierarchy over here that's WebAssembly specific.
Okay.
So WebAssembly itself, right, is what's called an ISA, right? An instruction set architecture. It's like x86 or ARM, right, or Apple Silicon, right? It's the instruction set that your CPU runs. It's just WebAssembly defines one that's a virtual CPU, right? It just says like, okay, here are the instructions that you expect things to run. So that's all WebAssembly is.
You have that as part of this idea of something, again, I didn't know the name of, but the platform target triple of when you're compiling things for it.
Right.
You're talking about like this list of things where maybe it's, built for UC x86 64 or something like that. And then from there, like Apple recently had the big change from using Intel processors to their own ARM processors. And so you'd see slightly different names for those triples or whatever.
Yeah,
because they're
exactly. So the
3 names with dashes in between them.
Yep, exactly. So when you compile an app typically you think about this at the C level, but like Rust and other languages have this exact same concept. You're compiling down to a platform triple, and the triple goes CPU architecture, machine, and then operating system, I believe, is the direction that goes. So, for instance, in this case, as you said, right, ARM. So that's AArch64. Typically, if you've ever seen that, that stands for ARM architecture 64-bit. X64 or x86 64, right? That's 64-bit x86, which what most of us run on our desktops. And then there's WASM 32, which is for WebAssembly, as is currently defined. And then the middle one is almost always unknown, right? Like you basically can ignore it. It's technically a triple, but if there's only two, the middle one's it just dropped. So most of the time you'll either not see it or it'll just literally be unknown.
Okay.
And then the last part is the platform or the OS. So that's where you'll see it say Apple or Darwin or Windows or Linux or whatever. And then in WebAssembly's case, that's where you'll see it say Inscription or WASI.
Okay.
And that dovetails nicely into the layers for WebAssembly, right? So WebAssembly, as I said earlier, is an instruction set of just telling like your browser or something, here are the instructions, go run these, and you know what they're supposed to do, right? Because it's designed for security and designed to be cross-platform, right? So it's agnostic, right? It's not like you can take x86 code and run it on your iPhone or something because that's ARM, or vice versa, right? Like you either have to do all the crazy stuff that Apple did to make Apple Silicon work, where they had their whole Rosetta technology to translate all that stuff and slow stuff down a bit, or you have to compile natively.
Okay.
And this one was just designed to work well in kind of a virtualized way, like running via software. The next step after this is the platform, right? Because you're not really running on Windows, you're not really running on Mac, you're running in some platform of WebAssembly, right? Emscripten is one platform.
This browser, if you will.
Yeah. So actually, Emscripten typically covers that for the browser, right? Because as I said, Emscripten kind of provides the APIs that you might want to use via the browser. So typically Emscripten is listed as the platform in that triple, right? Where it's WASM32-unknown-Emscripten, right? And then that's what provides you access to files, things of that sort, right? What you would consider something provided by your operating system, right? Like when you read through the Python docs and it says what OS is, what platform is available, Unix, Windows, whatever, like that's Mac, Linux, right?
Yeah.
That's what we're talking about when we say platform in this case. So there, it's not direct one-to-one anymore, right? It's not like, oh, I'm on Windows, so I get Windows. Like, no, you're running WebAssembly. This is a different world. And Emscripten is one version of this world. The other one is WASI. And what WASI is actually an abstraction. And basically what it is it lets you have it defines the API to access things that your platform or OS would normally provide for you. And then you use a runtime to actually provide the implementation. So example of this is WASI provides an API for reading a file. But it doesn't tell you how to make it work, right? What you do is you have a WASI runtime that provides the implementation of that actual function that reads from a file. And then it can control how you get that file. The reason this is important is because everything for touching outside of the code, like your system, has to go through those WASI APIs. And because it has to go through that, and those are not provided by default, right? The definitions are there, right?
Yeah.
It's like a C header file for anyone who's listening who knows C. It's defining what the functions look like, but not the implementation, right?
Right. This is what we want to be able to do and accomplish, and then you need to figure out how to implement it on.
Exactly. And then the runtime actually provides the functions, right? Like, okay, the code expects this function to exist. I will provide the implementation that makes it actually do the right thing. But the cool thing about doing that is those runtimes can provide security, right? Because now suddenly you can't read an arbitrary file on someone's machine anymore. If I give you some WebAssembly code that uses WASI, while Emscripten relies on the browser for its sandbox directly and the browser to give its API, I can let the runtime do whatever I want to do in terms of security. So I can totally take a runtime, the most popular one is probably WASM time, and tell WASM time, hey, when someone tries to read from the temp directory, make that temp directory actually be over here. on my physical system and have a very clear separation of what this code can access. Like when this code wants to read from my home directory, it's not my real home directory. Pretend it's this other directory that I purposely structured in a certain way so that they can only access it. Or you know what? No file access. You don't get any. I'm cutting you off.
Sorry.
Right? But it's the old problem of when you run solitaire, right, on back in the day, that app that comes with Windows, or at least used to come with Windows, it could technically delete files. But did solitaire really need file access? No, at best it needed a place to keep your high score. That was it.
Right. Okay.
Right? It needed one place to write one file to keep that one number somewhere, and that was it. It didn't need access to anything else, and yet it could totally wipe your hard drive. With WASI, the way it's designed, you can't do that because the runtime just doesn't give that access out. It's just like,
okay,
I want to read this file. It's like, well, okay, that directory doesn't exist, or that directory exists, but it actually exists in a different place that it's been sandboxed on your machine, right, with the right permissions and everything. So like you can't get to your root directory on your physical machine. You can only get into this little sandbox temp directory I made for you, and you can do whatever the heck you want, but guess what? I'm deleting it, and you're not going to affect my machine or whatever. So
okay,
it's an abstraction, but technically you actually could use WASI in the browser, right? Because it's just an API, you technically, and there is a proof of concept, I don't know if it's a proof of concept or just a demo shim available out there I've seen, where you can actually take WASI and shim it for the browser, and it still runs and it still works and still uses the web's API, right? It's like, oh, I want to read a file. Well, it pops up the thing asking you to choose the file to read. So it's not really a browser versus WASI thing. It's just WASI is a different somewhat concept, and just typically it breaks down to scripting because it just doesn't necessarily use WASI. It does as much as it can, to be very clear, but it will go beyond that. It doesn't restrict itself to WASI.
Okay.
While WASI is very specifically designed to be an API that people can target and say, like, I compiled for WASI, so I know as long as this stuff's provided, it'll work and it'll sandbox and protect it and all that stuff.
It's interesting that it feels like the virtual machine, in this case, WASM 32, is sort of needs a docking point, if you will, that is the runtime in order for it to, have access to the machine and do the stuff it's going to be. And so it could be docking inside of not using, it's just a term, but if you will, like kind of connecting to the browser or, connecting to, like you said, a runtime, this thing that is able to basically launch the virtual machine and give it its ability to, it's sort of like a brain connecting to a body or something like that, or something like that, having the ability to connect the stuff to it. I don't know.
No, that's a great analogy. And actually, I think it's a better analogy than you realize, because if you jump from the term docking to Docker, right, it's a similar concept, right? If you're familiar with Docker, right, Docker lets you mount things from your machine into the Docker container in a very specific way, like this directory mounts into the Docker container at that directory, right? You can restrict what network access it has.
Yeah.
It's all the same thing, right? Like there's a somewhat famous tweet out there from one of the co-founders, I think, of Docker itself, who said, if WebAssembly existed when we started to think of Docker, we just would have done WebAssembly.
We would have gone that way. Okay.
Yeah. So it provides that kind of similar layer of control and security that people have come to rely on Docker for, in terms of controlling how that code run in this sandboxes or in this runtime has access to everything else on your machine.
I had Russell Keith McGee on not too long ago to kind of follow up with him. I hadn't talked to him in 2 years, and kind of wanted to get an idea of, okay, what's going on with Beware and what's the state of that? And we discussed it a little bit. Like he's looking at all these different ways of like, okay, well, how am I going to deploy? That's the goal of Briefcase, is getting your app, your Python app, on other people's machines running, not necessarily for them to develop, but just to be able to have a runnable app. And, the targets very often are like an iPhone or an Android device or, Windows or what have you. And he solved a lot of them, and he occasionally bumps up against the problems that you have in like a phone and so forth, and has lots of tooling that has to get going there. And I asked him about, okay, well, you had a tool a while ago for deploying to the web, and it was like a whole other solution. And now he's like, well, I'm really kind of watching to see what happens with WASI and WASM and seeing if maybe that is the direction for briefcase and beware in the future.
Yeah.
Which I think is interesting.
So it's all very interesting, right? So because it's leading into some potential interesting directions, right? So as I said, there's kind of two sides of this. There's the inscription side of this, which has its own kind of approach and solutions to things, right? And it very much plugs nicely into the way packaging currently works, because as I said, pure Python code that doesn't try to use something that you can't have access to just works, right? The Python interpreter just reads the bytes, runs it for you. It totally works in WebAssembly, no problem. The trick is all those extension modules, right? Where it's written with some native code, whether it's C, Rust, Fortran, whatever. That's the tricky part. Now, for the script, and the reason this is tricky is the Python community, and this doesn't matter whether you're talking Conda or PyPA, like all of it. Because at the fundamental level, when you import something that's an extension module, what you're doing is you're doing something called dynamic linking. And what that is if you're on a Mac or Linux, you'll look and sometimes you'll see a .so file.
Yeah.
And if you're on Windows, that's a .dll. Okay.
DLL, yeah, dynamic link library. Yeah.
What's happening in Python is both platforms, both the Unix, and I'm grouping Mac in there, the Unix side and the Windows side, both have functions where you can say, hey, you know what, you've got some compiled code over there. I want you to read that and let me call stuff in there, right? So the way import works is when you import an extension module, what's happening is I'll just use the Unix side because that's the one I'm personally more familiar with. There's a function called DL open, which stands for, I think, dynamic load open.
Okay.
And what you do is you give it a path to a .so file. And what'll happen is it'll open it, and then it gives you back a thing. It's a struct. And then what you can do is you can use that to get to functions inside. So in our case, right, like when you write an extension module, you have to define that init function, which is named a very specific way. I believe it's pyinit _ and then the name of the module. So what we can do is when you say import spam, right, if we find basically, I'm simplifying here, but just to be clear, a spam.so file, the import system of Python and CPython can go like, oh, okay, you're trying to import spam. I found a spam.so or spam module.so, right? All right, I'll call DL open on that module, on that file, read it, and then I will look for a pyinit _ spam function, and I will call that. And then the thing that returns will be a module, and that will be what I use as the module for spam, right? That's how the entire ecosystem is designed. The problem is WebAssembly is not designed for that in any way, shape, or form. Because WebAssembly, for security purposes, wants to know about all your code ahead of time. By dynamic loading and linking, as I said, happens dynamically, right? When I'm running Python is when I tell it, oh, by the way, go import this code, go read this code and load it up dynamically, right? Like it may or may not happen. You don't know that file exists ahead of time, right?
Today we need to do this thing.
Yeah, exactly, right?
And yesterday we didn't. Yeah.
Exactly. You just grab the wheel off of PyPI, right, or install the Conda package, and in there happens to be some .py files and some .so files, and they may or not be there tomorrow. It might not be there just before I call it, right? I could have dynamically downloaded it and stuck it there before I did the import, right? Who the heck knows?
Right.
And then I load it up. WebAssembly does not want that world. WebAssembly wants to know about everything up front to make sure everything plugs together nicely. Nothing's got malformed anything that's going to somehow corrupt your system or crash or anything like that. Like it wants to verify everything works together, plugs together, nothing breaks the rules. And if I run this code, you're not going to somehow try to break out of the runtime and do something nasty to my machine. So the tricky bit here is how do we resolve this problem of WebAssembly wanting to know everything up front and the Python world having built around this entire world where that's not the way it's designed. It's just never been designed that way, right? We don't take, you hear people complain about like Python can't build to a single file. Well, like Go and Rust. Yes, that's true, but guess what? You also can't just download a random package and immediately get to use it in Go or Rust either, because you have to have that all ahead of time and compile it to a single thing. WebAssembly is similar, right? So there's pros and cons to this. So the pro for us is I just grab a wheel, stick it and unpack it in a directory, it's ready to go.
Yeah.
The problem is obviously distribution is a little harder. Go and Rust, on the other hand, get to compile to that one binary, much like WebAssembly does. But the problem is you have to download it and compile the thing into your single binary, right? The way Emscripten works around this is they have a little weird trampoline that they have at the JavaScript level. So what they do is at the browser level, right? Because in the browser at JavaScript, you're basically, there's literally a WebAssembly function you call. That's just like, hey, load this WebAssembly code and let me call functions at the JavaScript level. So what they do is your WebAssembly code gets compiled by Emscripten to say, hey, go out to JavaScript, have JavaScript read this, this extension code compiled for WebAssembly, load it up into another WebAssembly thing, call that code from JavaScript, get the result, give it back to JavaScript, and then go back into the code where I called it, right? It's called a trampoline. And so it's going from WebAssembly to JavaScript to WebAssembly. It's a hack, but it works, and it gets the Emscripten world a solution today to the problem of the Python community and pretty much any dynamic language being structured around this kind of dynamic loading of .so and DLLs. And we're starting to have conversations actually at the WASI level about how to solve this.
Okay.
So my day job is
to get out of the trampoline park.
Yeah.
Because it's not just a single trampoline. It sounds like there's lots of them lined up that you jump from one to the other.
Well, and it's not a standard either, right? This is just the Emscripten tool coming up with their own solution.
Yeah.
But it's not standardized at all, right?
Okay.
Like Emscripten is a tool that generates its own things. It has no compatibility guarantees between SDK releases or whatever. It's literally, you have to compile your whole world with the same version of Emscripten to get out the result, which is why it fits well with Conda, right? And why they're trying to take Conda Forge to do it, because you can just compile all of Conda Forge using one version of Emscripten and spit out all the WebAssembly for that view of the world, and they've all just worked together because it's all using the same toolchain. But the problem is that doesn't necessarily, that's one way to do it. But once again, it's also, you have to do that, and it's not a standard, right? And for my day job, I'm in charge of the Python experience for VS Code, and we're starting to look into using WebAssembly as a way to run Python in the browser for vscode.dev, right? And we decided to go with WASI because, as I said earlier, we have these APIs, right? So we can have VS Code implement those APIs so that when you try to read a file in WebAssembly, it actually reads from the code you loaded up into VS Code itself, right? So if you're on vscode.dev and you open up your GitHub repo, you can suddenly read those files, even though they're not physically in your browser. We're actually talking through to running JavaScript code that's then talking to GitHub to get those files pulled in, and then you can read it and process it and all that stuff. Very cool. But the problem is how do we get all those extension modules, right? Because it's great if you're just running pure Python, but as soon as you want to pull in NumPy, for instance, or anything else, you hit a roadblock. So I have been tasked to try to figure this out. So what I am now doing is I'm actually talking with the Bytecode Alliance, who are effectively the people in charge of WASI. It still kind of bubbles up to the W3C in the end, but the Bytecode Alliance is basically this group of companies that have all kind of come together around WebAssembly and especially WASI and are trying to kind of work through these problems. And they just formed a dynamic languages SIG. We have about biweekly meetings right now around Python and some other stuff called the component model, which is not critical to this conversation. But I'm now getting involved at that point, and we're starting to have early conversations about what does WebAssembly and WASI have to do to work better with these dynamic languages. Because up to this point, WebAssembly's, for good reasons, been kind of heavy on the Rust, heavy on the C and C++ code, right? All this stuff that, once again,
because it's compiled.
It's compiled and compiles down to that one file, which fits the security model really nicely.
Yeah.
But now everyone's going like, oh, you know, it'd be really cool to have Python or Ruby or PHP, like all these dynamic languages. And they're realizing, oh yeah, they weren't designed to compile down to a single binary. So this is a problem. So we're just starting to have those conversations about what could we potentially do to make this easier. Because the reason I'm bringing this up for Russell is my dream. And I'm not saying this is going to happen, to be very clear here. Right. My dream, though, is what will happen is we'll somehow figure out a way to not necessarily support dynamic linking in quite the way we do it now, but a way to at least at runtime, when you start up your WASI runtime, provide all of the extension module code, right? What would have been your .so or .dll pre-compiled in a way for WebAssembly, and have WebAssembly, the runtime, know how to pull that in up front and say, hey, you're going to use this. It all looks good. We'll consider it one thing together and now run it. Because if we do that, the interesting thing that opens up is suddenly you only have to compile your extension module once. And not only will it work on WebAssembly, but as long as you're running WebAssembly on any other platform, it'll also work there.
Yeah.
Because once again, WebAssembly is portable.
Right.
So it's a very interesting story potentially of, you know, how people talk about, oh, I have to go compile 23 wheels for every version of Windows, Mac, Linux, for all the different CPU architecture, different versions, et cetera, et cetera. Imagine if you only had to do that once for WebAssembly.
Yeah.
All right. It's an intriguing story, I think, personally, because in Russell's case, it's like, well, if we just package everything up as WebAssembly, then we just have to make sure WebAssembly's there.
Yeah.
And then you have to compile it once, and now suddenly it'll run on iOS, it'll run on Android, it'll run on desktop, it'll run on web. That's my dream.
Yeah. You just got to have the run times on all of those things.
Exactly.
Right.
Especially as long as there's a way to have, if there was a way, once again, dreaming here, I'm being very clear here, dreaming that there is a way that the WASI runtime can just go like, oh, hey, we can't exactly do dynamic loading, but we can kind of do ahead of time dynamic loading, right? Like, here's my compiled copy of numpy.so. Oh, you're going to want to load that in, and there's a function there you want to call. Okay, that's totally cool. You can totally do that. And, right, and just kind of upfront do that, pull it together at runtime, and just go like, okay, now go run. Right, that way I might have to download all my stuff up front, but at least I don't have to compile it with Python together at the same time, like you do with Rust or Go, right? I don't have that overhead.
Yeah.
I can just give you the file, and you just have to list it up front that you need to load all this together, and it'll just work, right? That would be fantastic, right? Because once again, portable. Any OS, as long as you have a WASI runtime on it, would be able to use it. And that's pretty much all of them.
Yeah.
So that'd be a dream of mine, right?
Yeah. This week, I want to shine a spotlight on another Real Python video course. We've covered a recent course on OOP, or Object-Oriented Programming, the method of structuring a program by bundling related properties and behaviors into individual objects. The course I'm featuring this week builds on the previous Python Basics course, Object-Oriented Programming, and both courses are built from a section of the Real Python book, Python Basics, A Practical Introduction to Python 3. This particular one is titled Python Basics, Building Systems with Classes. And in the course, Ian Curry takes you through how to compose classes together to create layers of functionality, how to inherit and override behavior from other classes to create variations, extending a parent class, and how to use the super function, and then how to creatively mix and match these approaches. Object-oriented programming can be a bit intimidating for someone starting on their Python journey. This course continues with a steady hand to lead you deeper into the topic. And like all video courses on Real Python, the course is broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. One of the things that you mentioned in the article, the WebAssembly and it's the platform targets for it, and we talked about, the target triple and all that sort of stuff, is this PEP 11, and which I think is kind of wild. How many PEPs are living documents that way? Are many of them that same kind of way, where like they're just constantly, need to be kind of updated? I guess maybe we should discuss what PEP 11 describes and lists.
Sure. So PEP 11 is basically the list of officially supported platforms by CPython, and it's what's known as an informational PEP. So if you go to peps.python.org, you'll see the list of all the PEPs that have ever been submitted.
That's new, right? That got like kind of organized in a way recently. The whole PEP website, is that right?
Yes, on your definition, depending on your definition of recent. In my time frame of Python, it's very recent in terms of internet time.
It's not that recent.
Yeah, sure.
Okay.
We were very lucky that about a year ago, we got some various people like Will Turner and Cam who got involved, who really took to the PEP repo and just really wanted to put the time in to clean it up and make it easier to work with, and added a lot of tooling around it. And we were able to kind of make the website a bit easier to work with.
Yeah, it's very easy to search and navigate now as an end user.
Yeah, we even have subtopic sections. So I think if you go to peps.python.org/packaging, you'll see all the PEPs that are only about packaging. I think there's a similar one for types or typing. I can't remember the exact subcategory name. But they've done a great job and made everything read a lot more easily. But yeah, so the deal is informational PEPs are ones that are kind of living documents. They're meant to provide information because the Python core dev team just didn't have, well, I mean, we're so old, we didn't really have a website, right? I mean, there's python.org, but the dev team itself didn't really have a dev section, right? Like I wrote the dev guide, devguide.python.org. That was one of the first dev specific things we really kind of wrote out and kind of covered all of our processes and all this stuff. And that postdates PEPs. So for a long time, we were using PEPs as a way to kind of record decisions we had made and decisions that we would revisit. And those are the informational PEPs where it outlines what the PEP's for, but we will update those PEPs versus accepted PEPs, right, that are standards track, which are updating the language or something.
Yeah.
In which case, they just become historical documents. We don't update them anymore.
Okay.
But informational PEPs are meant to be living documents. And PEP 11 specifically, as I said, lists the platforms we support officially. To some degree, it's tiered.
In WebAssembly, yeah, it's tiered and is tier 3.
Mm-hmm.
What's the idea between the tiers, I guess we should say?
Yeah, so there's 3 tiers. So first off, if your platform is not in a tier, it basically means a core dev is allowed to remove code that might break that platform.
Okay.
Right? It's just like AIX is a good example. We don't officially support AIX. So if there's some code in there that we want to make a change and it's going to break AIX support, that's totally fine. It doesn't matter. AIX is not officially supported, so it can just go.
Is it kind of we, not guarantee, but we plan this level of support for at these tiers? You can sort of expect this is what's going to happen. Tier 1 mentions CI failures will block the release of a release from coming out if the continuous integration won't go. And I remember watching releases of beta versions or what have you and so forth, and it okay, well, I guess this isn't going to go this time. We've had a problem, and we need to go back and make sure that these have to pass and get through before we move on. Is that right? The way to describe it?
Yeah. So each of the tiers just increases the promises that we make, so people can set their expectations for support for that platform, right? So tier 3 basically says you can't remove support for this platform.
Okay.
It can be broken, but you can't proactively remove the code saying, "Oh, this is annoying. I don't want this." No, you can't take it out. It might be broken, but you got to leave it there.
Okay.
Technically, to reach that level, all this requires steering council approval to be at any of these tiers. But for tier 3, other than that, you have to have at least one core developer listed as the contact point, so the person who basically owns the support for that platform. And you have to provide a stable build bot that basically helps people detect when they accidentally break something. The next level up is tier 2. For that one, you can break that platform for up to 24 hours, but after that, you either have to have fixed it or you need to revert your change. The reason is that level is because most of those platforms are only available as a build bot, so our whole testing fleet. So you can't test it during CI, so that's why you're given a 24-hour window. And that one, you had to have 2 core devs, because if there's a question and someone happens to be on vacation, the backup person basically has to make sure they're available.
The things that are in there, those are Apple's, the M1 series, the Arch 64, and PowerPC for Linux. Most of them are Linux, and then basically M1 Apple stuff. I'm hoping the M1 Apple stuff eventually moves into tier 1. So we'll see.
So the reason that's not there is because tier 1 is CI based.
Okay.
Basically, tier 1 says you are not allowed to even commit code if it might break something, right? It has to have already passed all of the continuous integration tests by running the whole test suite before you merge a PR for it to be allowed on, right? Tier 2 is just separate just because there's no way for us to know if you're going to break CI. So because basically we don't have CI support for Apple's M1, because Apple being Apple, they just don't make the hardware available to run in some data center somewhere, right? So for instance, in our case, we use GitHub Actions. GitHub Actions is available on Linux as x64, Apple for Mac x64, and for Windows 64-bit. So that's why those platforms are up there, is because we can just guarantee that everything turns green before we hit that merge button on a PR.
You can just see it.
And it should always be green and clean on main. Basically, the promise there is if you check out the main branch on the CPython repo, for those tier 1 platforms, it should always build cleanly and pass the whole test suite.
Okay.
Tier 2 doesn't make that promise. Tier 2 just says you might have to go back 24 hours, but within 24 hours, it should be fixed. But we can't promise that if you check out main, it's going to work, because there may be, as I said, someone may have accidentally broke something after they committed on CI, because it passed for the top, those 3, right, of tier 1.
Yeah.
But you don't know until we commit, because there's a lot of machines. These machines are all donated. Some of these machines literally sit under people's desks, and they're not always the most powerful machines. So we don't want to flood them with every PR and every change that people push. So
yeah,
that's why they're at tier 2.
Okay.
And in our case, for our discussion, WebAssembly is currently at tier 3. Although I have, maybe you might say, delusions of grandeur, but basically a goal of getting WebAssembly to tier 2 before the end of the year.
Okay. Yeah. Other things that are in 3 are like Raspberry Pi, in particular, like Linux. Actually, most of them are Linux. There's the ARM version of Windows, and then free BSD.
Yep.
Okay, cool. Yeah, it's so much interesting stuff underneath the hood. You got to kind of pay attention to, and your name's on there as far as the tier 3 contact for WASM 32.
Yes, I am lucky that I'm getting more and more core devs involved. Kushal Das is shown support. I just haven't needed to update that list, because once again, I'm on it, so it's covered for tier 3. But for tier 2, like Kushal, I think has said he'd probably be happy to be on there. Eric Snow, because as I said, VS Code wants to see Python and WebAssembly work really well, especially for WASI. So at least for the WASI support, there will be coverage to get this to tier 2. Honestly, I don't think mscripting will necessarily get there. This is going to be a topic of the WebAssembly Summit at PyCon US in 2 weeks from rough.
I didn't know there was that summit also.
Yeah, it's been invite only, just because I had to organize it and I can only handle so much.
Sure.
And I wasn't. We got a room for 20 people, and I wasn't sure how many people would want to come. So I posted on discuss.python.org under the WebAssembly category, just saying who would like to come. I have 20 people. Let's keep it to invite only for the very first one ever.
Yeah, makes sense.
And so we're getting about 10 people. I'm sure there'll be some random people who will pop in saying, can I just come and sit or whatever, or people who forgot to reply. So we'll luckily not go past the 20, but I also didn't want to have to play bouncer at the door either. So I have purposely not broadcast to the world, there's a WebAssembly summit. If you're interested in WebAssembly, like, yeah, there's only 20 seats. So it's very focused on people who are involved.
Okay.
But yeah, I'm hoping to get WASI at least to tier 2. I don't know about Unscripted. We're going to have to discuss that, just because, as I said, for work purposes, I'm directly interested in WASI. And to be frank, it's easier to develop for, because it's a direct compile target and you don't have to get Node or anything else involved to run the test suite. Because you just run WASM time and it's done. Versus the browser, you've got to load up Node or a browser in the background and all that. It's a bit more involved.
Okay.
So we'll have to talk at the WebAssembly Summit about how we want to support that.
So it potentially still would, the runtime, like you said, WASM time, will that run on multiple types of machines? Like, do you have to download your version of WASM time, the runtime, for running on Mac or for running on Windows? Then you need to get that particular.
Correct.
Okay.
WASM time is written entirely in Rust, so as long as there's a Rust tool chain, you can compile and run it on that OS. But yes, there eventually you got to get down to some software to run this stuff, because there's no WebAssembly CPU. Physically plugged into your machine that can run this stuff for you.
Right.
So yeah, at some point you have to hit that platform. But at least in this case, you just need that one runtime for any WebAssembly, whether it's Python or not. And
this is weird because it still has WebAssembly in the name, and so it like immediately like, oh, it's still going to involve a browser, but it really isn't in this case.
Yeah, it's a little bit of a misnomer at this point. So the thing is WebAssembly, because of its security promises, is gaining a lot more traction in a lot more places, right? So, for instance, it's starting to get used in IoT, right? Because you want to be able to securely deploy stuff to small devices.
A lot of those things are insecure. We hear about it all the time.
Insecure,
right?
They're small devices. You don't know what kind of chipset you might be targeting, right?
Yeah.
So it kind of abstracts away like any random little embedded CPU you might be running against, as long as you have the runtime on it. compiled for it. The code still is the same. You just got to make sure you have the runtime. So it kind of makes that simpler.
Okay.
If you use Disney Plus, right, and you have the smart app on your TV, that's WebAssembly.
Okay.
I don't know how many people know that, but they have a blog post on at some Disney engineering blog talking about how they targeted WebAssembly to do all this, right? So your TV is running it because most of those apps on your TV are actually web-based.
So it goes back to kind of the idea of write once. Like I can...
Yeah, exactly. This is what Java tried to do on their own, but hopefully now with all the learnings we've had over the subsequent decades of Java's creation plus the W3C and everything behind it, and so many companies buying into it, hopefully this will be the right once run anywhere kind of scenario.
Okay.
But yeah, and then Docker, for instance, right? Once again, people are starting to get interested in this in terms of cloud deployments, because suddenly, instead of having to orchestrate entire VMs running Docker and downloading all this stuff and good example, right? Let's say you just want to run this one piece of Python code, right?
Yeah.
If you want to do that with Docker, you've got to find the Docker container, you've got to specify what you want to install, download it all.
Got to have an OS specified.
Yeah, and Alpine Linux for Docker containers exists just because there's all that overhead and kind of bloat to just run that little thing.
Yeah.
And so why do I have to go through all this? Especially if it's like, I mean, just to be generic, right? A Rust or Go binary, or as I said, just one Python interpreter with your Python code, right? There's a lot of overhead to download a multi-100 meg thing, to then spin up Docker, to then load that thing and provide all that. Or you know what? Here's the WebAssembly file, just go run it, right?
Yeah.
The overhead is significantly less in terms of what it takes to orchestrate all this stuff. So this is why, as I said earlier, some people have suggested, like, had WebAssembly existed back when Docker started, it may not have been necessary. And people have just realized this since WebAssembly was created. So yeah, it was created for the web, but it's not tied to the web. Right. So I think this is why probably people are starting to lean into just calling it WASM more than just saying the whole WebAssembly name.
Yeah.
Because it kind of makes that disconnect happen.
Leave the web out of it. Yeah, potentially.
Yeah, exactly. I mean, it's awesome because
it's still going to have to be distributed, but yeah.
Exactly. And it does mean that there is a WebAssembly runtime in everyone's device, because every browser now has support for WebAssembly. So it does mean it's prolific.
Yeah.
But yeah, it's not restricted to the web at all anymore, because, as I said, everyone's realized there's all these other benefits to it. And if they can make this work in terms of ecosystems, there's going to be a lot of wins in a lot of ways.
Me on the sidelines watching this, I feel like it's one of the faster moving technologies I've seen in a while. I mean, outside of maybe the unmentioned AI or whatever you want to call it, LLMs and stuff recently.
Yes.
On a different front, as far as distribution and kind of movement, like, there's still stumbling blocks that we've kind of brought up in our discussion already, but generally you can see the green open field out there and saying looks like it's gonna happen, and not, are there things that are unseen that you can think of that are like, well, this could block it or could cause it from becoming a standard?
So, to be frank, there's too much money involved now for it to not go somewhere.
Okay, too big to fail.
There's too many people involved with it. There's too many people who've sunk engineering costs into it. Right. Like, for instance, Fastly, the CDN company, is a major player of this because they're actually using this to do their cloud play for edge compute.
Okay.
Right.
Well, you mentioned Disney. That's a pretty big investment from them.
Yeah, exactly. Right. So there are various companies that are putting serious dollars behind this and really creating technology that they're heavily leaning on, that they would not want to have go away. But to be very clear here, it is early enough that, like, WASI is considered preview 1 right now.
Okay.
There's going to be a preview 2. And then I believe after that, they're going to add async. And after that, they're going to be targeting a WASI 1.0 release in terms of the spec.
Okay.
So it's still early enough that we're still talking in terms of previews for these APIs and not 1.0s, but I don't see it going away. And from Python's perspective, it's honestly not that difficult to provide support.
Okay.
Right? Like, a lot of the hard work Christian did back in 2022 in terms of getting the patches from the Pyodide folks that did a lot of the initial work, and then some tweaking here and there, But for instance, when Christian was doing this, he found bugs in the tool chains for WASI, right? So, and he reported them, and luckily it's active enough right now that they got fixed, and next release had the fixes, and we were able to pick them up and go with it. So it's not been a struggle per se, but it is new enough. Honestly, CPython has a history of finding bugs in compilers, so this is not a first for us. I've personally reported bugs into GCC and Clang LLVM because of CPython. So we've done this before. But I think there's enough momentum that's going to keep going. I think the question for us as the Python community is going to be, will we be given the tools necessary to make this a nice, smooth, easy experience? Or are we going to have to build a bunch of tooling around certain limitations because we're not provided certain things in order to make things work, right? As I said, for instance, the dynamic loading of extension modules is a perfect example, right? Like Emscripten has their kind of crazy hack, right, to make their things work. But so they've got something, but it's not ideal. WASI currently doesn't have anything.
Doesn't have it. Yeah, okay.
If they don't, it's not the end of the world. You could actually... And we've contemplated this, and I have some people at Single Store Labs who are participants in all this on the Python side have actually done a proof of concept where they basically wrote a mini C app that embeds Python, right? Because you can actually embed Python in a C app as part of its design, and they basically just statically link in, so compile in NumPy into the binary, and then they just point the Clang as the WebAssembly compiler at that C file, just say compile that, and it just acts like a Python interpreter. It just happens to ship with NumPy built into it.
Okay.
It's not the worst thing in the world, but it's not the easiest thing either, right? But if we did somehow get my dream to come to fruition of, oh, well, I kind of compiled a .so version of WebAssembly that these runtimes can just consume at runtime, do whatever they have to do to validate it, and just go with it, that'd make everyone's life way easier. So that's kind of where I'm at in this whole story. Is I don't think WebAssembly itself is not going anywhere. Python and WebAssembly, I don't think is going to go away. I think the question is going to be, how much does the community latch onto this, and how nice of a story can we make it for the community?
Yeah.
That's where I'm currently at in this story. And as I said, I'm now participating at the level of the Bytecode Alliance on behalf of Python. So
I love that name.
I'm in the dirt. I'm in the mud. I'm playing around. I'm helping out as best I can. But we're also talking about like standards and companies involved and all this stuff. So it's not going to move at the speed of AI as it seems to be moving at this point. But
sure.
It's definitely still moving forward. And everyone's just trying to be very conscious and very considerate about what happens here, right? Because once again, we're playing in someone else's sandbox in this case, right? It's WebAssembly sandbox. We're just trying to help out and be participants and good participants. Yeah. So it's not going to move as fast as someone can write a PEP. It's going to move as fast as everyone can come to consensus in the Bytecode Alliance, the W3C, right? Because all this has to bubble up that way and all that stuff. But people are talking, people are working, and it's all slowly moving forward. So I have hope.
That Bytecode Alliance names makes me think of this company I saw once that it was like they did like audio apps and stuff, but they were called the Bit Cartel. Kind of makes me feel like the same kind of idea, but awesome. Well, I thought we could talk a little bit about PyCon just kind of briefly.
Sure.
I think this might come out after it, but you're scheduled to do your talk on Saturday, the 22nd, and your updated, refreshed talk.
Yes.
And then you're involved in the language summit, right?
Yeah. So I'll be attending as a core developer and as a Python Steering Council member for the last time as a Steering Council member, actually.
Oh.
And then I'm actually going to be presenting a topic on what is the standard library for, or what should the standard library be? I don't have a good title for it because it's kind of hard to squeeze into a title slide, but effectively what I want to do is I want to ask the room, as a core developer of almost 20 years, actually I'll hit my 20-year anniversary the day before the language summit, actually, and as a Python Steering Council member for 5 years, I still can't answer the question of what should or should not go in the standard library based on what the whole team thinks, right? I have my opinions, but everyone's got varying opinions. And there's no document or guidelines as to what we expect the standard library to represent and do. right? Like, should it handle networking top to bottom? Should it be for system administration? Should it be stuff that abstracts other stuff out? Like I could, if you came to me and said, hey, Brett, do you think this should go in the standard library? I'd have to go, well, my opinion's blank, but I could never give you a general guideline of, well, this is what we expect the standard library to build to do for somebody.
Yeah.
And so that's what I want, is I want to have this conversation. And we talked about this earlier about informational PEPs and kind of living documents. I eventually, from this conversation, went to be able to write a informational PEP that says, kind of, here are our guidelines as to what we think thematically belongs in the standard library. If you want to propose a module for the standard library, check that it meets one of these themes. If it doesn't meet one of these themes, we're probably going to say no. If it does, there's at least a chance we'll say yes.
Yeah, I think that word belong is a good term for it.
Yeah.
Maybe to include in that, yeah.
So that's the conversation I'm going to have, and I'm sure it's going to be an interesting one.
Yeah, I might imagine it might be pretty animated.
Oh, yeah. People have opinions on this one.
Yeah, well, you had done some research, I don't even remember when, but about looking at kind of what are the sort of dead batteries or things that are in the standard library that are potentially not being touched or used. Maybe there are multiple people involved in that process.
Mm-hmm.
How's that? There's things that are marked for deprecation. I don't think that date has happened yet.
It's not happened yet.
Okay.
So there was a dead batteries PEP that Christian Himes wrote, and then I became a co-author of to help finish. And it basically stripped out a bunch of modules that we just thought weren't getting used enough to warrant the cost of maintaining them. Because something I think everyone kind of forgets is someone's got to keep that code working.
Right.
And it falls on the core dev team. And there's only so many of us who actively participate, let alone want to fix bugs in some random module that doesn't really affect our day-to-day lives or our personal projects or anything that we get paid to work on, right? So for those lucky enough to get paid to work on Python. So it was basically going through and just in a very loose conservative way, just going like, that seems too old or not useful enough to stay here, not used enough to warrant sticking around.
Yeah.
And then going and asking the community and other core devs, would you cry if we took this away from you? And then cutting out some things that were on that list because too many people were going to go, no, please don't, no. And
based on the volume of tears.
Kind of, yeah. And then trying to be extra conservative here because we did this once when we moved from Python 2 to 3. And it just seemed like it was a good time to do it again because as I think I blogged about once, before we did this, there were more modules in the standard library than there are countries in the world.
Wow.
Right? Like it's nearly... I can't remember if it broke 200, but if it didn't, it was just shy of 200 modules.
Yeah, that's a lot.
Right? I don't think we'll quite realize the breadth of it. If you go look at that module index, it's huge. So that PEP actually got landed, and I believe I think it all landed in PEP in Python 3.11. So I believe Python 3.13 is when we're going to have a nice culling of the standard library for a bunch of stuff that's due to be taken out.
Yeah. Well, I'm looking forward to talking to you, hopefully seeing there in Salt Lake City. And thanks for coming on the show again.
I look forward to seeing you too in about 2 weeks. And thanks for having me on.
And don't forget, start sending relevant and timely product notifications for your web and mobile apps for free with Courier.com. I want to thank Brett Cannon for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.